Greetings and thanks for stopping by at the eCave today. In this episode I'll continue with the analysis and repair of my TRS-80 Model 1. If you're interested in that, please stay. Thanks for staying. As I mentioned, this is the second episode on the TRS-80 Model 1. I came to the conclusion last time that I needed to replace the video SRAM chips because of faulty bits being stuck on and painting zeros on the screen, plus creating garbage. As it happens, I received 5 brand new SRAM chips from Bulgaria a few days ago, and I've continued to have a look at it, so it's time to get stuck into it. However, before we do that, I thought I'll explain to you some of the things I've discovered in the process. If you recall last time when I was opening up the case, I noticed a botch wire on the motherboard. Oh, yes. Ooh, there's a botch wire here. I was wondering what that was for, but I didn't think much about it until later on. I was putting the oscilloscope to the video divider chain, and all the frequencies didn't match what the technical support documentation was saying. So in the end I worked out that what was happening is that this particular version of the TRS-80 is a PAL version, and the bodge is there to modify it to produce 50 Hertz. But more than that, they've replaced the master crystal oscillator with a slightly lower frequency in order to get the horizontal frequency closer to the PAL standard. So let me show you on the block diagram I've created, and you can see the frequencies, and I'll also show you what they actually did with the bodge and what they changed. As you see here, here's my block diagram in all its glory. Let me zoom in a bit so we can see the video divider chain. Now, when I was measuring these frequencies in the divider chain, they were all incorrect. That led me to suspect that this system had been modified in some way, and lo and behold, it has. To achieve the PAL type horizontal frequency, what they've done is they've replaced the master clock with another crystal which is marked 10.483, which is about 0.43% slower than the NTSC crystal. But what that gave them is that dropped the horizontal frequency from 15.840 kilohertz down to 15.591 kilohertz. That's close enough to the PAL standard, which is 15.625 kilohertz. When it came down to the vertical, I was still measuring it 649 hertz instead of 660. And if you divide 649 by 11, you can't get 50 Hertz. So this is where they made the bodge. They've actually changed the counter here from dividing by 11 to divide by 13. So I'll show you here on the schematic what they've done. Basically, they've cut the trays going from Z66 pin 2 up to Z32 pin 9, As you can see here, this is set 66 and pin 2. This is the trace that goes to pin 9 on set 32. And they basically cut that trace and put a bodge wire from pin 2 to pin 8. And as I said, this binary counter will then divide by 13 rather than divide by 11. In that way, they achieved the modification to PAL frequencies, so European and Australian users wouldn't have problems with their monitors. That was interesting, wasn't it? When I was beginning these repairs and discovered it was PAL, I thought to myself, surely there must be some documentation on this. But I've been completely unable to find anything in relation to the PAL modification. It's at least you know now, if you have such a system, what frequencies to expect. Next, I decided to use the logic analyzer and the oscilloscope to verify the SRAM chip that was causing the problems on the screen. As you may recall, I had data bit 7 grounded, so it wouldn't cause any trouble on the screen. I corrupted, and I suspected data bit 4 from the SRAM creating those zeros. So, of course, I took off the grounding for data bit 7, expecting to see the corruption. But lo and behold, it was very shy, so I had to forego showing that to you again. But trust me, it does come back again after a while. I then used the oscilloscope and then used the logic analyzer. So I'll show you both methods to look at which data bit is causing the zeros. I've thrown up the schematic of the S-video RAMs to show you where I'll be probing both with the oscilloscope and also the logic analyzer. For the bit 0 to bit 5, I'm probing directly on the output of the S-video RAM chips and also on bit 7. However, as you'll note, there is no bit 6 video RAM. They skimped on that to save money. They create a pseudo bit 6, which is up here, and if you look at this thing, it's basically taking data bit 7 and data bit 5, pushing it through a NOR, so whenever the data bit 7 and data bit 5 are both low, you get a high in the output for data bit 6. You can think of data bit 6 like an offset into the character generator. But enough on that. These are the probe points for all the data bits. And as you'll notice, data bit 6 is on set 30. Pin 13. That's why that probe is further away from all the others. Now, before I do the probing, I want to put the screen into a condition that I know is supposed to be all zeros. Because if one of the S-video RAM is outputting a 1 when it shouldn't, I want to make sure every other video RAM is outputting zeros. To do that, I put in a bit of a program to poke null into all video RAM locations. I'll show you that a bit later. It's out of the basic level 2 reference manual. The strange thing though is when you put in null and poke it into all the video locations, null is supposed to be all binary zeros, but the screen is actually showing the @ symbol. Now, why is the screen showing an @ symbol when it should be showing nothing? Well, that's again because of data bit 6. If you look at all the data bits here, they'll all be zeros except 6, because data bit 7 and data bit 5 are low. The NOR of 7 and 5 is high. What that does is creates a binary 0, 1, 0, 0, and that's the offset into the character generator to create an @ symbol. Yes, pretty strange. When you think there's a bit missing, you can use a routine to poke in to make all of them ones instead. That's an option. And here I'm showing the logical analyzer hooked up to the data bits on the board. I'm using 8 of them, and then I'll show you the program I wrote, which is a basic program from the reference manual. As I said, basically it's poking null into every video RAM location, and when I run it, as you see, the screen fills with @ symbols. What that should do is make all the data bits low, except data bit 6, of course, which is not really a data bit from an SRAM. But now it's time to probe with the oscilloscope, beginning with data bit 0. First we'll have data bit 0 out of video RAM, and that's low. Data bit 1 is low. Data bit 2 is low. Data bit 3 coming up is low. And then data bit 4, not low as it should be. So something wrong with that. Data bit 5, low. Oh, sorry, didn't hit the pin. Low. Data bit 6 is high. And data bit 7 is low because I've grounded it here. With that, let's look at the logic analyzer. And here we have my logic analyzer user interface. I've captured a few seconds of the screen with the @ symbol. And as you can see, I've got data bits 0, 1, 2, 3, 4, 5, 6, and 7. And interestingly, data bit 6 is high, as you can see, all the time. 0, 1, 2, 3, and 5 are all low. But when it comes to data bit 4, it is on, and it should not be on. And you can see the @ symbols being interpreted here, and in between there are the zeros. So this tells me for sure, not that I wasn't sure with the oscilloscope, that data bit 4 is outputting spurious 1s from different locations. So it's time to replace data bit 4 and data bit 7 and see what happens. I've taken the ground strap off data bit 7 from the S-Video RAM. So let's turn it on. Now I haven't turned it on for a while, and I've noticed before that it looks fine for a while before it goes corrupt. Well, we'll leave that in there, but data bit 4 from the S video RAM. I think we need to see if we can get rid of those zeros first. That would be this chip here, Z61. That's data bit 4, which does all the zeros here. So let's swap that out and see what happens. Sometimes you go all the way under the socket, and you don't want to do that. Yeah, I better have the ground strap on. Don't want any unexpected things to happen. So put this in here. Let me just double check the pins before I push it in. Sorry about my head being there, but all right. Let's see what happens. Would you look at that? All the zeros are gone. That's excellent. So what I'll do, I'll run a basic program to print out the character set. So let me find that. Okay, I found it. It's in the basic level 2 reference manual. So let me type that in and we'll see if we get the characters. It's a bit awkward doing it over the board, but let's see. Those are the decimal codes for the upper part of the character set, where the graphics characters are. So there's the routine. Let's run this and see what happens. Okay, not too bad. All right, we start with 1 to 9, which are the alpha numeric characters, and then we go up to where the character set graphics characters are. They're just blobs, miscellaneous sizes. But I'm pretty sure I need to replace video RAM 7 because I'm pretty sure it will corrupt again. So let me see. I'll change 50 to go to 10. So I want to run it in a continuous loop. See how that goes. Yes, we have some glitches in there. So let me replace the database 7 S video RAM. So hopefully this will go a bit faster. Practice makes perfect. that didn't go too well either. Anyway, that's one out. And we have a new one, which hopefully will not get corrupted. And then we'll be having a system which is fully functional. Yep, that did go better. So let's power on. Two new S-Video RAMs, databit 7 and databit 4. That looks good. $16K system, brilliant. There's more stability and no glitches. And if I try that routine again, and let's run it like this first. Brilliant. Looks good. I think I may need to adjust the vertical and the horizontal hold, but I'll do the voltages first, given that the screen is fine. Excellent. I've yet to clean up the keyboard, and as you may have noticed, I've put a ribbon cable here with headers. It's something I have to fix up a bit better when I put the case back together again. I was very happy to see it working again, because this is a very old hardware and I'm glad it came alive. Now, of interest to me was to see whether I could hook it up to the original 10D video monitor. The one I have is the US-based one, 110 volt. So I did that next, so let's see what happened when I did that. Okay, everything's set up. As I've said, this is the US version of the monitor, so there's no transformer inside. I'm just using a external 240 to 110, so I'll turn that on and then turn on the TV. See if we get anything. Yep, and now comes the crunch. What will we see on the monitor? I have no idea. Will we see anything? Well, no, we're not seeing anything at all. Sounds like, or looks like, I'll have to go and investigate why we're not getting any output on this guy. Whether it's related to the fact that it's PAL and the monitor is expecting NTSC, or whether it's something else. That'll be interesting to find out. Unfortunately, nothing is here, and I can't see anything on the monitor itself. No visible video whatsoever. So that's the vertical, the horizontal. Yep, further analysis required. That was disappointing. Nothing, zero zilch. Not what I expected. I thought I had it fixed, but definitely doesn't look like that. I didn't know whether this was because there was still something wrong with the video monitor, or whether this was incompatibility between the PAL version of the Tandy and the monitor being made for NTSC. In the end, I took it to my bench, had a look at it, and it was a perfect opportunity to try out one of these portable oscilloscope, battery operated, especially when you're working with these TVs or systems where the chassis is not grounded. It's actually the neutral from the AC. So a lot of things can happen if you're using a normal oscilloscope. So this acts like an isolation, so you can view your signals. Anyway, what that led me to was once again that video board, which is powered by the TRS-80. It sends plus 5 volt into it, and on that video board is a optocoupler. And I could see the video go into the optocoupler, but nothing was coming out on the other side, and some of the voltages on the other side weren't according to the SRAM's computer facts sheet. What I did then was I whipped out the optocoupler, put a new one in, and bingo, everything started humming again. So that monitor is working. And I could actually sync both the vertical and horizontal and get it operational. So I can use that monitor. However, to power this US monitor, I use the external 220 to 110 transformer, which is quite bulky and heavy. And I don't want to be lugging that around or having that humming somewhere in the background. So I went on eBay to look for something smaller and neater I can actually fit inside the monitor. And guess what? I found this. This is like a travel plug. It's 100 watt max. It actually does 110 to 220 or vice versa, with a flick of a switch here on the back. I plugged the monitor into this and then into the 220 volts we have, and it works fine. So what I'm planning to do is somehow fit that inside the monitor, and then I don't have to worry about lugging along or a transformer external to it. So a brilliant solution, simple and elegant. With that sorted, I took all the key caps off the keyboard and cleaned them, and I cleaned the keyboard as well, or the base. Now I use dental tablets, so I just put the key stems into a Quality Street box, bit of water and a couple of dental tablets, and leave it there for an hour or two, shaking it once in a while, and out come the keycaps perfectly clean. But I also use 303, which is a car interior polish, to polish them up before I put them back. Now for the base, there was some rust on the base, and the matte black paint seemed to be hammered away in places. So I simply got some rust stopper, put it on the rusty bits, and once I did that, I simply used a matte spray or matte black spray and a pencil to pencil over again. I didn't fancy desoldering all the key stems from the board underneath just to get at the frame to paint it. because I tested all the keys and they were all working fine. I of course put in some electronic contact cleaner into the key contacts, and that fixed one or two keys that were a bit slack. But after that, they all respond normally and every key is working fine. Now, that only left me with the issue of putting the ribbon cable. I had a very long ribbon cable. I put some headers. I simply cut it and took one end apart and reattached it back in a shorter version, and I'm hoping that will fit into the case. And the last thing was the cover I 3D printed for the I/O port, finding the paint for it. As it happens, I went to a auto store here in Australia called Super Cheap Auto. They do color matching for automotive paints, but they don't have anything to scan. You basically either have to tell them the code, or they've got like a printed copy with samples of all kinds of colors. I browsed through that sample paper color thingy until I found the silver colors, and as you can see, I think this one seemed to give me the best match. And when I asked them for a spray can with that color, unfortunately they said they were out of spray cans, so I had to come back later, and I finally got my spray can, and I discovered the mixing in the can wasn't very good. I had to shake it very vigorously to get thin streaming out of it. But after getting that worked out and spraying the cover several times in very thin layers, you can't apply a thick layer or it leaks all over the place. It's better just to spray very thin layers a few hours apart, and it looks fine. I'm quite happy with it. So this is what it looks like now, and I reckon it's good enough. I could have sanded the cover a bit more and got it completely without any blemishes or dimples, but I think it's fine. It's not something that I'm going to complain about, given the fact that the unit is working very well and it looks the age, and the cover looks the age as well, so I'm happy with that. I've now finally put the whole system back together again. I've hooked it up to the Tandy video monitor, and I've even loaded a game, as you can see beside me. Everything seems to be working fine, so I'm very happy to see this old system back together again, fully functional. It's taken a few days and a few hours of my time, but it's something I really enjoy. One of the things I noted though while I had it hooked up to my PAL monitor was I saw some glitches in the vertical sync. I'm not sure what might be causing that. I do suspect something around the Z5 vertical shaping circuit, or maybe the adjustment resistor used to adjust the vertical hold. I'll show you a video clip of one of the glitches. It's hard to catch them, but they do occur from time to time. If it's something you've come across before or know about, by all means put a comment so I can find out what you did to fix this. Other than that, as I said, I'm very happy, and for now I'm saying thanks for stopping at the eCave.